Okay, everyone, let's come back together. Okay. So on behalf of the Russell Sage Foundation, the Alfred P. Sloan Foundation, and Duke University, it's my pleasure to welcome you back to the Summer Institute in Computational Social Science. So today we're talking about surveys. And now we are going to talk about the next part of what we can think about as the third era of survey research, and that's computer-administered interviews. So previously we talked about non-probability sampling and sort of who we end up talking to. And then now we're going to think much more about what we're going to learn from these people when we're actually talking to them. So the switch from human-administered interviews, which is what we're generally using now or have used in the past, to computer-administered interviews, I think this enables certain kinds of changes, and it also requires certain kinds of changes. So let's think a little bit about what this enables. So actually, let me just say one other thing about cost. So a lot of people say, oh, let's just switch to computer-administered interviews, like online web surveys or robocalling surveys, and that will just save costs. And they just try to keep doing the same thing they were doing, but just at lower cost. And even though I said before, cost is a really important consideration, let's also try to think about what are some new things that we can do now with a computer-administered interview that we couldn't do before with a human-administered interview. So these include things like breaking up a big survey that's usually answered outside of people's, like, if you think of a telephone survey, it's long and it's removed from the context of people's everyday lives. They stop what they're doing and answer your survey. You can imagine a survey instead where you cut up the question, you cut up the big instrument into little pieces, and then those pieces get sprinkled into the everyday lives of the people. So this is sometimes called experience sampling, where your phone will ring or buzz and you'll answer a survey question in the moment where that thing is actually happening. So that's an example of something that's really only possible if it's all automated. It would be very difficult for someone to call you at that moment and talk to you and get you to answer that question. That would be very, very expensive. But if it's automated, it's something that can be done much more cheaply. So let's think about the kinds of things that this enables. And let's also think about the kinds of things that are required. So generally, if people are doing these computer-administered interviews, I think there's likely to be lower levels of engagement and potentially lower levels of response. So filling out a web survey is potentially a very different experience than having someone sitting in your living room talking to you. And so I think if we don't make changes to make the data collection more engaging for respondents, we're going to have lots of problems. And more generally, I think social scientists are used to designing data collection for somewhat captive populations. So in these surveys, often, there's nothing that prevents you from hanging up the phone, but if you're talking to a person, there are norms against completely hanging up the phone. But if it's an online survey, there are no norms that prevent that person from just closing the browser. And in fact, that person is just one click away from the skateboarding dog. And so you have to realize that you're designing an instrument for a non-captive population. Similar with experiments. Any of you have designed lab experiments, psychology-style lab experiments. Those are really not generally very fun. And it is true that people can get up and leave those, but it's also true that they're unlikely to do that. And so if you're going to design an experiment online, you might have to deal with the fact that it should be enjoyable for people. So what if we could use computer-administered interviews to do things that weren't possible easily before? And what if we could potentially make the process of having people give us data more enjoyable? So the research that I'm going to talk to you about now is research that I've done with Karen Levy. And that project was really inspired by this website. So if you go to kittenwar.com, you will not hear another thing that I say today. You will definitely see 2 pictures of kittens. You will be able to vote on whichever kitten you think is cuter. And then a new pair of kittens will come up. And then you can vote again and again and again. And before you know it, you spent 20 minutes clicking on kittens. So in addition to being a really enjoyable way to spend time, there's some other important stuff that's happening here. So if you look to see what are the winningest kittens, this is what you would see. These are pretty cute, I would say, in my professional opinion. If you click to see the losingest kittens, this is what you will see. So it's very different. Let's go back to the winningest kittens. So the other thing about these kittens that's really interesting to me is that all of these kittens were uploaded by users. And so if you think about the way, let's say a sociologist would normally try to find the picture of the cutest kitten in the world, we might go to the library and we might resort to theory and try to guess what we thought the cutest kitten might look like. Or we would go to the library and look at a bunch of books that have pictures of kittens, pick some that we thought looked cute, put them on a survey, and then see what people say. But even in the biggest university library, probably does not include the cutest kitten pictures in the world. Like, the cutest kitten pictures in the world are probably somewhere else. And it's not clear to me that we want to impose so much of our own ideas into the construction of the instrument. Like, what if we just don't have a good sense of what a cute kitten is? Or what if we're designing our survey for a country that we've never been to? So ideally, you wouldn't be doing research about a country you've never been to, but it has been known to happen. How are we sure that we're not baking in the wrong things? And so this is generally a problem that's well known about surveys, which is that they're generally not open to new information because you've written all the questions and all the answers. And more generally, there's this fundamental tension that underlies a lot of the way we collect data. We have some methods like surveys that are very good for quantification, but they are not open to new information. This is a known problem, and that's why we have other methods like interviews and participant observation and focus groups, which are much more open to new information, but those are slow and expensive and hard to quantify. And so what if we could try to come up with a hybrid new method that would combine the quantification you get from surveys with the openness that you get from interviews? And so that's what we tried to do, and we called them wiki surveys. So just like Wikipedia evolves over time based on user input, imagine if you had a survey that evolved over time based on user input. And this would potentially give you both quantification and openness. So another way of thinking about this is that Kitten War has solved a fundamental tension in social science research collection, and we're just going to build the Kitten War for social science. So before doing that, though, we thought, let's try to think about what general properties a wiki survey should satisfy. So like, let's think really about the properties that we want for this new instrument. And to do that, we thought a lot about traditional surveys. And then we also thought about websites that have a lot of user-generated content. And so if we took these user-generated content websites, the principles that help them work well, and the principles from survey research, and combine them, this is what we think these wiki surveys should be. So the first general principle that we came up with is greediness. And so let me explain a little bit more what I mean by that. So this is a cartoon schematic of the amount of information that's contributed to Wikipedia. So the x-axis here is the contributors sorted by rank, and the y-axis is the amount of information contributed. And so there are some people who contribute to Wikipedia 40 hours a week, or 80 hours a week, let's say. So these people, small number of people, contribute a lot of information. And then there are also lots of people who contribute a small amount of information. someone adds a comma occasionally or adds a citation to a paper. And so one of the things that makes Wikipedia so successful is it's able to harvest this full range of effort. It's able to take the effort from these people who are sometimes called the fat head, and it's also able to take the people from the long tail. And so Wikipedia is able to take as much as you are willing to give. Now, this is very different than traditional social science surveys and also experiments and other techniques that we use, where we take a fixed amount of information from each person. So if someone comes to you and says, I love your survey, I want to do it 100 times, first of all, we would probably say, are you okay? Like, because our surveys are so boring, no one would actually possibly want to do them. And then we would say, no, this is going to create all kinds of problems in my analysis. So we say, if you want to contribute a lot, sorry, you can only contribute this much. Likewise, if someone comes to you and says, you know what, I'll give you 2 minutes. You can have 2 minutes of my time for your survey. We would say, oh, no, sorry, can't do that. That's going to create something called item non-response, and that's going to cause problems for me. So we say, all these people, we don't want your information either. So by taking a fixed amount of information from each person, we're losing the fat head and we're losing the long tail. So to give you some sense of how much information is included in all of that, let's use Wikipedia again as an example. So if you allowed 10 and only 10 edits per person, they would lose about 90% of their edits. This is like a huge amount of information here and here. So we want to capture all that information. So we want to be greedy. The second principle is that we want to be collaborative. And so by that, we mean the respondents themselves should have a role in shaping the instrument, not just the researchers. Because again, there are a lot of things out there in the world that we don't know and we would like to learn. And so the best way to do that is to have the respondents help shape the instrument. And the third principle is that we should be adaptive. So by adaptive, I mean, if we cared about the respondents' time, then we would only want to ask them the questions that are the most important questions for us at that moment. If you think about the way a lot of surveys are designed, generally we write all the questions in a certain order, and then we, let's say, do 1,000 interviews. And by the time we've done 500 interviews, though, we know much more than we knew at the beginning. But we're not able to use that information to make the instrument more adaptive, right? We're not able to use the information we collect as we go on to be more and more efficient. So if you cared about the respondent's time, if you treated that as a valuable commodity, what you would want to do is say, I'm only going to ask you the most important question right now. And you, so we want our new instruments to be adaptive. So let me just briefly say that collaborative and adaptive seem similar, but they're different. Let me explain the difference. So collaborative is about being open to new information, and adaptive is about using the information we have more efficiently. Okay? So we said, let's try to create something that has these three properties. And so not just, so we got a grant from Google to build a system that has these three properties. And that's the website we have, allarideas.org. It's free and open source. Anyone in the world can go and create their own wiki survey there that we host for them. And this provides a nice service for the world. And it also gives us a source of data and participants for us to do future research. So let me give you an example of what happens in one of these wiki surveys. This is a project that we did with Mayor Bloomberg's office. It's no longer the mayor. So he wanted to, New York City has a long-term sustainability plan in trying to make the city greener. It's called Plan YC 2030. And he wanted people to be able to participate and add new ideas to go into this plan. And so Mayor Bloomberg's office did a number of things. They hosted public meetings, there were city council hearings, and all kinds of other outreach to residents. And one of the things that they realized is that when they have these in-person outreach, they tend to attract a certain kind of person who is able to come and spend time participating in the government. And they realize there are lots of other people who maybe don't have time to go and show up at these city council hearings, but would also like to be able to participate. Another problem they had is imagine going to a community meeting of New Yorkers where they argue about the future of the city for 3 hours, and then summarizing all that information in a fair way. So pretty much everyone is going to feel like their view wasn't fully included appropriately in this report. So they wanted also a system where the process of aggregating that information would be more transparent as to how that happened, and the output would be easier to interpret. And so they, in addition to the other activities they did, they also created a wiki survey. And so what they did is they came up with a question. So which do you think is a better idea for creating a greener, greater New York? And then they seeded the wiki survey with 25 ideas that they had from previous outreach efforts. Things like require buildings to make energy upgrades and so on. So one of the things you'll notice is that all of these ideas are relatively short. This is not a place for your manifesto about the future of democracy or something. And that's intentional. So we limited all the ideas to be 140 characters. And that, again, is designed to make the data the process of participating a more enjoyable one. And so then our website creates our own wiki survey for them, allorideas.org/planyc. And so you see this question, and you see 2 ideas here that were randomly chosen from the pool of ideas. A respondent can vote, and then 2 new ideas come up. They can vote again and again and again. And then at any time, anyone can click to view the results. Also, at any time, anyone can click this big button here to add their own idea, which then goes into the queue to be voted on by others. We have a question.
We have a question from the live stream. So Elliot from New York City wants to know how you filter junk inputs and questions, both poor quality questions or intentionally junk questions from bots intended to disrupt the survey.
It's a great question. So the short answer is we didn't do that. One of the things about the way the wiki survey platform is set up is that all of that moderation is done by the wiki survey creators, not by us. So that decision was made by the mayor's office. But I can tell you a little bit more about what went into their thinking, and I can tell you a little bit more about the general patterns that people use to try to deal with this. So obviously, I would not recommend including anything that is profane or factually inaccurate, extremely factually inaccurate, and so on. In terms of preventing, but this is a fine line because you don't really know what is a good idea or not. You think you know what people will be interested in, and so I generally encourage people not to screen out what they think are bad ideas because they don't really know if it's a bad idea. Another question that comes up is dealing with duplicates. I generally say I would include pretty much everything unless it's a word-for-word duplicate, because one of the things that we'll see later is that the same ideas expressed in slightly different ways can receive different levels of support. And so it is not for you to decide what is a duplicate. It is for the participants to decide what is the same. And so the philosophy here is in surveys, generally, we're very used to being constrained in what we can do. We're like, oh, we have to standardize this. We have to choose the right way of expressing this word. And like, let's just imagine a different setting. Like if you run ads on Google, have anyone ever tried to run search ads on Google? You don't try to pick like the one best ad because it's hard to know what's going to resonate with people who are searching. So you throw in like 100 variations of the same ad where you change each word slightly, you change the order, and then you see which one works best. And like if it turns out they all do the same, then you've learned that they're all the same. And oftentimes one will do better than the others, and that's because it's really hard to anticipate what's the same and what's different. And so what if we had surveys where we're much more willing to just have a bunch of things and let the people decide whether they're similar or different? So, yep.
I think that's a super nice idea, the wiki surveys. I'm currently thinking how bad persons could manipulate it. So we learned about web scraping, for example, you know. Let's say I don't like the idea about green in New York, and I would come up with a bot farm. Or would I even need a bot farm? Do you need users to log in?
Yes. Okay. It's a good question.
Yeah, so that's the first thing. And then I basically can manipulate, right? I could pick answers that I like. I create accounts, or I do votes and votes and votes again. Maybe I set up several accounts so that you don't have one user which is like voting a lot of stuff. So how could you prevent this, or at least try to get an alarm thingy going?
Great. This is a great question. So let me talk. We do not have accounts, and I want to talk about why we don't have accounts. So we don't have accounts because we want to reduce the barriers to entry to participation. So if you look at other online participation systems, when we looked at them, and my sort of feeling from them, this is not based on research, this is based on feeling, is that the higher the barrier to entry, the more only people who have extreme views are going to go over that barrier to participate. And so the more complicated it is to do, the more you're sort of setting up extreme people to participate. So we wanted this to be as easy as possible so that everyone could participate. There are questions about manipulability, and I think around this time, there were other online systems where people can see a ranked list of ideas and vote for the one they want. So President Obama, for example, did use this Google moderator system. And the #1 ideas in a bunch of topics were all related to legalization of marijuana. Because people just went and voted. A bunch of people said, hey, marijuana people, let's go and vote for these issues. There's a couple things that make manipulability harder than it initially appears. One is that you don't choose what you vote for. We choose the pair that you can see. So if someone uploaded like legalized marijuana, and you told all your friends to go and vote for marijuana, you would actually have to cast many other votes before that could show up. It is possible to do certain kinds of automated voting. I will say that certain forms of automated voting leave a very distinctive signature, and we have ways of looking for that, and we have ways of dealing with certain kinds of attacks. So the way that we think about making the site more resistant to these attacks is we see an attack, we develop a countermeasure, and then we deploy that countermeasure, and then the next attack has to be more complicated. And then we try to defend against that one, and then we do, and so there's definitely ways to defeat the defenses that we have. I'm 100% sure of that. I'm not going to announce them publicly. But this is a problem, actually, it's related to a lot of other online systems, that there's a desire for transparency. That is, you all, if you are going to be users of this platform, might want to know how are we preventing certain kinds of attacks. But on the other hand, if I tell you the safeguards we have in place, that makes them easier to overcome. And so I think this is a place where there's a tension between protection and transparency. That's a tension that arises in lots of real online systems as well. Questions? Yep.
I was wondering if you had thought about how to reconcile the collaborative principle with potential demand effects. So basically, to collaborate, you need to know what the purpose of the survey is. Have you thought about how to reconcile those?
Yeah, so there's a question about how, there's a more general question also about how you communicate what's happening to the users. Because this is also not like a survey that people are used to. And so as I've worked with many groups and users, I realize how much we are trained to understand what a survey is. People are like, oh, a survey, I know what that is. It has an end. This has no end. You can keep voting as long as you want. So people are like, how do you have a survey without an end? This is very unfortunate. I've gotten some emails from people who are like, when is it end? I want to stop. So it's a challenge that we've had to communicate to people, the users, what to expect. And it's also a challenge that the wiki survey creators choose with the types of ideas they have to make it clear to the users what is sort of in scope and out of scope. So even though it's open to new information, the seed ideas help set a context for what the other ideas that will eventually get uploaded are. Okay, I'm going to keep going, and we can have a lunch discussion table about wiki surveys if we want. Or no, maybe tomorrow. We'll have plenty of time to talk more about wiki surveys. I want to show you the results, and I want to stay on schedule because we want to start talking about linking surveys and big data. So what exactly are we trying to estimate? So generally, as I said before, it's important to know what you're trying to estimate. So this is the data structure that we have here. There are votes that are nested within sessions. So there are no accounts, but we can have a sense of what a session is. And roughly, a session is like an individual person participating at a single time on a single device. Then we can see the pair, and we can see the thing that the person voted for. What we want to estimate is what we're calling an opinion matrix. So for each session, for each idea, we'd like to know how much the person in that session liked that idea. And if we knew this full opinion matrix, then we could do lots of stuff with it. Now, so the New York City, they launched this. They recruited a bunch of people using non-probability sampling methods, like sending out a bunch of things on Twitter. I realized this is not a probability sample of people who live in New York. There is nothing, though, that would prevent you from taking a probability sample and then putting a wiki survey on top of it. So again, emphasizing the modularity between the sampling process and the interviewing process. These two things are separate. In this case, though, it was not a probability sample. So this is what we found. So this is the number of responses per session. So there was one session that had about 800 responses. So we saw these people, a small number of people contributed a lot of responses. A large number contributed a small number of responses. So this is just like the Wikipedia graph, except this is real. This is real data. Also with the uploaded ideas, similar thing. A small number of people uploaded many ideas. A large number of people uploaded a small number of ideas. So we designed a system to have this property, and it actually had that property. Here are the results. So the score is the estimated probability that this idea would beat a randomly chosen other idea for a randomly chosen session. So it's a summary of that bigger opinion matrix. And the score goes from 0 to 100. Higher score is better. All of the ideas that are in blue were uploaded by users. So 8 of the top 10 ideas were uploaded by users. I want to talk briefly about what kinds of things were uploaded by users that scored well. And I'm over time, so I'm going to go a little bit faster. But the beauty is that we have a whole paper about this where we explain everything in great detail. Alternative framings, where people take an idea that is already known, but they express it in a different way. So this was keep NYC's drinking water clean by banning fracking in NYC's watershed. So we asked the mayor's office, don't you know about water quality? And they're like, of course we know about water quality. And we were like, well, why wasn't that in any of your seed ideas? And they're like, well, because this person talks about fracking and connecting that to water, and we didn't think about it like that. But when you add the word fracking, it becomes something that people are very engaged with. So it's not a new idea, but it's a new framing of an existing idea, which can be very valuable. And so survey researchers sometimes think of these as bugs. It's like people are more likely to support aid for the poor than they are to support welfare. That's a bug. Why aren't people more consistent in their beliefs? I think that's actually a feature, right? That is telling us something about the world that's important. The second thing was actually novel information. So these were things that the mayor's office was not aware of, at least the part that we were working with. So plug ships into the electrical grid so they don't idle in port, reducing emissions equivalent to 12,000 cars per ship. So this was not something they had thought of before, and it's something that eventually ended up in the plan, a version of this idea. So that's a little bit about wiki surveys. I want to talk a little bit. This graph shows why I will bet you a beer or a coffee or whatever you like to drink, that if you do a wiki survey, the best scoring ideas will be uploaded by users. I think it's a simple mathematical fact, and it's described more in the paper. I want to talk more about this as a sort of way of doing research. So I think a lot of times research is very hard. You have to work really hard to do a paper, and then you have to start again and work on the next paper. And wouldn't it be great, though, if it got easier and easier? So the idea is that we can create this kind of virtuous cycle where we have this website that brings in more users. More users enables us to do more research. More research enables us to have a better website, and so on. And so then things get easier and easier. I will say in practice, this is very hard. Yeah, so we can talk more about that offline. So we're currently hosting about 12,000 wiki surveys with about 18 million votes. We've had users from governments, so the House of Representatives in Brazil and the UN. We've had different social movements participate. Different companies have used it as well. But I want to say one thing about, we've talked a lot about access to data a little bit. How can we partner with companies to get data? I also want to say, you can also just create your own data, right? You don't need to partner with companies. And if you think about the amount of time it takes to partner with companies, and you think about the amount of sacrifices that may be involved, and if you think about the amount of time that fails, if you took all that time and energy and invested it into creating something on your own, you might be able to do something like this. We are, I think, out of time for questions, so we're going to go on to the next chunk. We are way out of time, so we're going to go to the next chunk. And then the reason why we're going to not have questions, though, is because we want to have a lot of time for you to do this yourself. But if anyone has any questions for me about the wiki surveys, the statistical models, or the process of doing it, or what it was like to try to create your own system, I'm happy to talk much more about that. OK. Combining surveys and big data. So at the beginning of the day this morning, I talked again about Fountain and David. And now I want to talk really about how we can combine these two. So in the sort of overall arc of third era of survey research, we're now in this part of the arc. Will big data kill surveys? I hope I've convinced you that the answer is no. And in fact, I think a better metaphor than one thing killing another thing is peanut butter and jelly. So for all the Americans here, I hope you grew up eating peanut butter and jelly sandwiches because they're so delicious. So peanut butter and jelly are examples of things that are complements to each other. So the more peanut butter you have, the more jelly you want. And likewise, the more jelly you have, the more peanut butter you want. It's not that one will replace the other. It's that they're complementary. And so I think we can think of it also as digital exhaust and big data sources and surveys are like peanut butter and jelly. And so I want to talk more about how this different recipes for peanut butter and jelly sandwiches. I think there are really two main recipes. The first is what in the book I call enriched asking, where you have some big data source, you have some survey data, and you do a one-to-one record linkage between them. And so in this case, then you use the entire thing for research. So this is a very natural model. I think this can start sometimes with the big data source, or it can sometimes start with the survey. And this is a model where you have to do sort of record linkage. Here is amplified asking. And so this is more like the Blumenstock study that I talked about on the first day, where you have some big data source, you have a small amount of survey data, you use the survey data to build a model, and then you use that model to impute the survey data for everyone. So in this case, I want to highlight, though, what is the role of the big data source? So here, you directly care about the big data source. It has stuff that you will eventually use in your research. Here, you don't end up using the big data source at all. So once Blumenstock used the big data source to impute this survey data, that was it. No more phone records. Just focusing on the survey data and the imputed survey data. So this is, I think, one of the biggest differences when the way that you combine these things. And also, what that means is that this big data source can be anything, even something that you don't care about at all. So like, let's say he could have records of like people's browsing on the internet or something. You might not care about that at all. But if that can be used to predict a survey answer that you care about, then it can be useful to you if you're using this recipe. And so what I want to talk about now is I want to talk more about this design. This design, I think, is good, and I think this will be used a lot. But I think that you don't need to hear me talk about this very much. There's a lot of issues. I talk some about them in the book. But I want to talk a little bit more about this because I think this is a bigger change in mindset. And so we'll spend our time on that. So now we're going to see the paper we saw before, but hopefully I will explain it to you in a different way and get you to think about it in a little bit different way now. So as I said last time, starts with the call records. 1.5 million customers of this mobile phone company. Getting access to this call records is potentially one of the hardest parts of this research. Call records don't have what you want. You're interested in poverty. So you do a survey of a randomly sampled set of people from these call records, and then you link them together. So I want to talk a little bit more about the feature engineering process. So here, one way you could do it is you, as a researcher, could try to think of what the right features are to predict this outcome. So if you're not used to machine learning, by the way, you can just think of this as a linear regression. So I want to build a linear regression that's going to predict some measure, a continuous measure of poverty. And I want to know what are things about people's call records that could go into that linear regression. So you might think number of international calls versus number of domestic calls, or something like that. He was worried that he might not create all the right features, and so they created like this vocabulary system for creating features. So like, they knew that days of the week might be important, but they didn't want to know. They didn't want to specify that in advance. So they said, OK, we're going to take every possible day of the week, and then we're going to take, let's say, reciprocity is a measure that you'd be interested in potentially. So how many of the people that you call you back, or how much are you just calling other people? How much are they calling you? So those are two different features, like day of the week or reciprocity. But then he combined them. So he had reciprocity for every single day of the week. And then you could imagine adding in more things into this sort of vocabulary of features, which you then sort of automatically generate a huge variety of features, some of which make sense to you as a researcher, some of which might not make sense to you. You could describe what they are, but it's not clear why they would necessarily be important. And the reason they did this process is they wanted to be open to new features that they hadn't thought of. Then you build a model. So now we have a problem that they have an enormous number of features. And so then you can run into issues of overfitting, which we'll learn much more about on Friday, when you will do this process of building a complicated machine learning model from a high-dimensional data set. And so they did a certain kind of thing to prevent overfitting called, they did elastic net, a kind of regularization. We'll talk more about it on Friday. But the point of this here is that if you're going to do this more open-ended feature creation process, then you need to account for that in how you do this modeling step. Okay? Then once they have the model, they impute everyone's answers. They then impute the residence location. And then then they do this. This is a cross-validation result that I showed you before. So how well, for the people in the sample, if you pretend you don't know some of their wealth, you train your model, and then you try to predict the wealth of the people who you pretend like you don't have. This is how well it does. Not perfect, but there is some signal. The predicted wealth is related to the actual wealth. But again, this is not the quantity of interest. This is like a sanity check, basically. In a lot of computer science, this is often the quantity of interest. Here, this is not. This is a step in that direction. So then they were able to produce high-resolution spatial estimates of poverty. So this is a map of Rwanda. This grid is a 1 kilometer by 1 kilometer grid. So these are incredibly small geographic areas. And how well does this work? This is impossible to validate. There is no one who has produced estimates with this high of a resolution. And so when they compared to the Demographic and Health Survey, they had to aggregate to a much higher level, to the region. So this is, again, if you're doing a new kind of measurement, it can often be very difficult to validate that measurement because no one has ever done that measurement before. So in the Xbox survey thing, we talked about how you can have some baseline that you're comparing against. Here, there's not really a baseline because no one's ever done this. And these actually never got validated, right? The only thing that got validated was the regional level estimates. And so here are the regional level estimates from their approach and from the Demographic and Health Survey. And again, we see reasonable, but certainly not perfect results. This also, as I said, was 10 times faster and 50 times cheaper. I want to be clear, though, about where those numbers come from now. This was 10 times faster and 50 times cheaper if you don't, it depends how you count the costs. So, right, so like, I don't think Josh was paid while he was doing this. Everyone who's working on the DHS is getting paid. So like, as you, that changes some of how you would calculate the cost. It's also the case, though, that this would get much cheaper and faster as it became routinized. The DHS is very routinized. They've done it a lot. And so that enables them to bring down costs. I think in this case, the particular cost that's not included in this is the amount of time it took to get the data, which was enormous for obvious reasons, and also treat that data safely. So this is, again, a great example of combining ready-mades and custom-mades. Just leave this for a second. This is, I think, the future. Now, I want to talk a little bit more, though, about the trajectory of this research project. Because I've showed you the end. I've shown you the paper that was in Science and like the one that I personally think is just great. That was not the first paper in this trajectory. So there was the first paper in this trajectory was about modeling churn. So for those of you who don't know about churn, is a big problem that a lot of industrial data science is related to. So if you own a mobile phone company and you want to, one of the things you might want to know is who is going to leave my company? Because that is something you want to avoid. So what you have in your data, you have a bunch of call behavior, and you have a bunch of records about who has left the company or not. And so one thing you might want to do is you might want to have someone create a model that predicts whether someone is going to churn, and then you could potentially intervene and give them coupons or something so that they won't churn. So that was one of the first. Now, that may sound like that has nothing to do with social science at all. But the techniques that were used are very similar to the techniques that were used to measure poverty. So basically, in these churn models, you have some outcome, you have some call records, you have to do feature engineering, and then you build a model to predict the outcome from the call records. The only thing that's different is the outcome, in this case, in the poverty case, was changed and collected with a survey. So I think sometimes people see like a bright line between some of the stuff that's done in industrial data science and the stuff that's done by social scientists. And I think that bright line is not really that bright. Like slightly different ways of asking the question can mean a lot of these things can be repurposed to do social science research, or social science research techniques can be repurposed to do industrial data science. Then he has a paper where he actually does a first version of this actually related to predicting poverty. This paper, the results are actually pretty disappointing. Then he realizes he does some different kinds of feature engineering, he does some different kinds of machine learning, and then that leads to the paper that you see in Science. So the point is, you shouldn't necessarily expect that the first thing that you ever do with a piece of data is going to end up like this, and that often these projects involve a sequence of things, and things can get better and better as you learn more and go. Okay? Yeah?
Why was the second one a disappointment? Was it like inaccurate or something?
OK, so the question is, why was the second one a disappointment? I will let you all, you can read it, but I will say one thing is, two things. One is they were trying to predict individual survey questions. And in the later paper, they were trying to predict wealth, which was an aggregate of survey questions. And it turns out it's much easier to predict this aggregate of survey questions than an individual survey question. Also, the feature engineering was improved from this paper to this paper, and the machine learning was improved. I think this paper, in computer science, often there are these conferences, and so they have deadlines. And so I think this was like, this is where I am right now, and we'll see. So Now I want to tell you about something that has come after this paper, a new thing, which I think illustrates the generality of this recipe. So this paper came out, I believe, a year later, combining satellite imagery and machine learning to predict poverty. So a different big data source. We often don't think of satellite imagery as a big data source, but it is in the sense that it's something that's not created for the purposes of research. Like, in other words, let me just emphasize this a different way. When people think of big data sources, they often think of online stuff like Facebook or Twitter. Sometimes they think about mobile phones, but really we should think about big data sources as anything that's collected at kind of a bulk scale and that's digital. And so this paper uses satellite imagery, and it's a really surprising paper, at least to me. But I want to talk a little bit about how you can see. I'm going to show you how they did this paper, but I want to show you how this paper is related to the Blumenstock paper and how it's related to lots of other things that you will encounter. And it's this idea from machine learning that's called supervised learning. And it's one that I think social scientists are not used to seeing, but it's one that comes up over and over and over again in computational social science. So basically, you have lots of pairs where you have some inputs and some output. And what you want to do is to learn a function that will allow you to predict the output from the inputs. So you could think about spam, for example. You have a bunch of emails. You have labels about whether they're spam or not spam. And you want to be able to build a model that will predict the output. So supervised learning can be, this is an example of a supervised learning task here, where you have this trace data, the call records, and you're using it to predict the survey. In a different part of Bit by Bit, in chapter 2, we have an example where there are social media posts, and we want to know about their sentiment. And so we hand label that sentiment for a sample of them, and then build a model, and then estimate the sentiment for all of them. So that comes up when working with trace data, big data sources. Here's something from the human computation chapter, which you'll read for Friday. This is about galaxies, labeling galaxies. It seems like it has nothing to do with anything we're talking about. So they have a bunch of galaxies. There's a way of turning each of those pictures of a galaxy into a bunch of features, like how blue is the picture, how much variation is there in their brightness of the pixels, how much of the picture is non-white, and there's all these other properties you can imagine. They have some hand-labeled classifications about whether the galaxy is elliptical or not elliptical. And then you can, again, imagine training a model and then essentially labeling all these other galaxies. So all of these are really the same recipe. And you can use this recipe in many, many settings. And now I'm going to show you how they use this recipe with satellite images, because it's actually an even more subtle and complicated version. So that's supervised learning. We'll get some practice with doing supervised learning on Friday. But for the social scientists who haven't seen this before, it's basically, a lot of it is just a version of regression, right? You have some, regression is a thing where you have inputs, you have outputs, and you try to train a model to match the outputs. It's a very similar thing. OK. So the question, though, would be, what if rather than trying to engineer these features by ourselves where we think about what they should be, what if we could just learn them automatically from the data? And so this is a very popular idea now. It's sometimes called deep learning. This is a nice review paper. Came out in Nature maybe a year or two ago. So they use this idea. So to get the information out of these satellite images, rather than trying to have a human expert say, OK, this is what this image looks like, this is what that image looks like, they tried to use deep learning. Or, as this headline in Vice, artificial intelligence is predicting human poverty from space. So you talk about the hype cycle. I think this is a beautiful version of this headline. So just to show you, satellite data is totally available. So here's a picture of Kigali, which is somewhere I went to do a research project a few years ago. And you can see that we can get, not only does there exist very high resolution imagery, we can get it like just on Google. You don't need to be in the CIA to have access to this data. So now let's imagine that we had data like this from all over. How would we use this to try to measure poverty? So in the past, people had used data about how much light there is at night. So imagine if you see a place where this is Manhattan, there's a lot of light there. That's a sign that there's potentially a lot of wealth. And if you look at other areas, like for example, North Korea, there's very little light at night, and this is a sign there's potentially a lot of poverty. So people had used this night lights before to make estimates, but they don't do a very good job of distinguishing among relatively poor places. Like there's potentially a lot of variability in wealth at the bottom end that's not well captured by the amount of lights there are at night. And so this prior research has used these night lights. And so what they did in this picture is they used this research, they used day pictures and night lights and survey data. So the trick that they had was a way of getting information out of these pictures during the day that would allow them to be able to create a bunch of features, which they would then connect to the survey data to do a prediction. So I just saw the sign that we have 0 minutes left, and I am also not an expert in neural networks, so I will not attempt to explain this in detail, but let me try to give you the intuition, which is you have these daytime pictures. You try to learn the features from these daytime pictures that will predict how much light there is at night. Then you use those same features and you combine them with a bunch of survey data from the Demographic and Health Survey, and then you are able to see the relationship between the daytime features, like is there a paved road or a dirt road? Are there tin roof on the house or is there wood roof on the house, or things like that. The neural network learns to distinguish those things. It doesn't put those same labels on them, but it learns these things from the pictures, and then you can combine that with the survey data. So let me show you you could obviously read the paper. They explain it in more detail. Here are some results from multiple countries where, again, they're using the Demographic and Health Survey data. This is the observed consumption. This is from the Demographic and Health Survey, and this is the amount of predicted consumption per dollar per person per day. And so you can see one of the nice things about this paper is they use multiple countries. So one of the things you might think about what the Blumenstock paper as well, that worked in Rwanda, but maybe there's something specific about that phone provider or something specific about the patterns of phone ownership in Rwanda. So here we see similar-ish patterns across many countries, which is promising. Here we see an important result where you can see if you train the model, a lot of these techniques require you to have some high-quality survey-based measure which you're using to train your model. So in other words, you can only do this where you already know what the right answer is. So that's a big problem. And so in this paper, they also go beyond the Blumenstock paper by trying to train a model from one country and then use it on another country, which is a much more realistic setting. So you might, let's say, get training data from Nigeria and then use it to make estimates about Tanzania. So does that work well? That's a very, very important question. And this provides some evidence that that works reasonably well. In other words, the results that you learn from one country can potentially be generalized and work well in another country, subject to all the caveats in the paper. So why have the computer learn the features? Why not just have a graduate student actually look at those pictures and label whether the roads are dirt roads or asphalt roads? And the answer is because of the way they scale. And this is another picture. So one schematic we'll see a lot is that supervised learning schematic. Another schematic that we'll see a lot is this, thinking about fixed costs and variable costs. So as the number of images increases, let's think about the two costs of these relative approaches. So the graduate student labeling approach has low fixed costs. Like we could start pretty much right now starting to do these labels. But then if you want to increase the number of labels by a factor of 10, you have to increase your cost roughly by a factor of 10. So it's low fixed cost, high variable cost. The approach that uses neural nets has the opposite cost structure. It's very expensive to get started because you have to learn all this stuff and train all these models. That's complicated. But then once that model is working, you can potentially do as many images as you want. So this allows you to work in a very different data regime where you have way more data than you're ever used to seeing. And so I think an exciting thing as researchers, we can think about what is it that we could do over here if we had 10 times more data, 100 times more data, 1,000 times more data than people have had before. But the only way we're going to get that is if we use these low variable cost approaches. That's the only way to get enormous amounts. Generally, these low variable cost approaches have high fixed costs, startup costs. And so I think increasingly we'll have to see how we can bear those startup costs so that we can then have this good scaling in terms of the cost per unit of data. OK, so all the code for that paper is available. And to wrap up, surveys and big data are complements and not substitutes. Sometimes we do enriched asking where we just stick the two things together. Sometimes we do amplified asking where we use the big data source to help make guesses about other people, and then we use those guesses themselves, and we don't care about the big data source itself. And you can learn more about these approaches in the What Comes Next part of Chapter 3. And now we have time for some questions, maybe. Yeah, good. We have time for some questions.
So this came in from the live stream earlier this morning. So Maddie from Helsinki wants to know how much openness and transparency we can expect from organizations in terms of the methods they use. Both sampling was the question, but also other types of estimation maybe. And Hanling from Chicago wants to ask you what you think about how to consider the temporal factor in the type of methods used to collect data. Mm-hmm. So going back to sampling, for example, in polling, we might want to see real-time trends. So how might different survey approaches have advantages over each other to consider temporal factors?
Sure. So temporal, let's talk about that first. So there, I think having a low-cost technique is really good. Naturally, right? So if you want to do more estimates, if you get the cost down, that's possible. The other thing about some of these approaches that combine big data sources and surveys allow you to fill in this kind of temporal trend. So for example, let's imagine that, let's take the case of the Blumenstock et al., the cell phone data. So let's imagine you've trained a model where you have features of cell phone calling records predicting poverty. And then you want to you could set up a graph that shows you that graph that we saw predicting poverty to this like micro regions of like 100 meter by 100 meter regions. You could create that graph and update that graph every day as you get new call records. Right? So you can have estimates basically continuous. Now, are those estimates going to be good? That's the important question. And here I think a very important thing to keep in mind about trying to do this thing is keeping in mind that the big data source itself can change. So let's imagine the company creates a new policy where they say, oh, we're going to have a new marketing campaign. We're going to have free international calls on the weekends. And the company may do that. It's a great thing for the company. And all of a sudden, your estimates are going to get totally thrown off. So the way to handle that problem is to continually recalibrate what you're doing. So you should never think that you're going to train one of these models and then let it run for all time. That's just a bad idea. And you should think that you're going to continually have to do recalibration. And I think this is actually a great ad for one of David Lazar's papers. So the Google flu trends, part of the problem that they ran into was they weren't recalibrating enough, and that Google changed its policies, and the modeling didn't account for that. So if you want these estimates over time, you need to continually recalibrate, and you need to be aware of changes in the data generating process. The first question from Maddie was about transparency, and I think that's very important. And very hard. So often if you want to often researchers are in a position where they want to buy access to a sample from a provider. So like YouGov, for example, is a company. You can go to YouGov and say, I have a survey. I want you to give it to 1,000 people. It is very hard so I believe my sense of things, I've not worked with any of these companies. My sense of it is that YouGov is a high quality company. They want to be transparent, my sense is. I don't think there are certain things that they can say. And I also I think that what they're doing is so complicated, transparency becomes very even difficult to imagine. Like at what point, if a thing is so complicated, it's hard to even be transparent, even if you want to be transparent. So I think in some ways, there has to be some trust involved in sort of, if you're working with someone else, to have confidence that they're doing what they're doing appropriately. And then in terms of transparency from big data sources, if you're combining them with surveys, you would often want to know things like from the mobile phone company about maybe they had in the past, they had these sales on weekends versus weekdays. Ideally, you would know that so that as you were training your model, you could account for that. Often that information is no longer recorded because these are new foo, new boo. Like the mobile phone company does not think like, oh, I need to keep track of what sales I ran 2 years ago just in case someone wants to do a bunch of stuff with historical data. Okay. I think we are going to switch to the activity. Okay, so let's take a 5-minute break, get refreshed, and we'll be back in 5 minutes. And now you are going to do your own survey. Greg, are we? Okay. Hi, everyone. So on behalf of the Russell Sage Foundation, the Alfred P. Sloan Foundation, and Duke University, it's my pleasure to welcome you back. We're going to talk now about the group activity for surveys. This activity is designed to be done in kind of a modular way. So people at the partner locations, your organizer may have different ideas about how exactly you all are going to do the activity. I'm going to describe the way we're going to do it here. And I'll try to point out areas where I think people may branch and take different approaches. So this also means for all of you, if you all ever have a class that you're teaching about computational social science, you can also take this activity and repurpose it for your purposes as well, because all of the stuff is posted online. Okay. So we talked earlier about this Xbox study that used this large non-representative sample to do a very good job of estimating the support for President Obama. And the next step in that line of research was this paper about could we take a sample from Mechanical Turk, use some of those same techniques, and then produce estimates that were similar to estimates from high-quality telephone surveys. So let me explain a little bit more about why we would want to do this. The biggest is that it cuts the cost enormously. So doing a high-quality telephone survey is expensive, and doing one of these things on Mechanical Turk is cheap. So I think in the paper, they estimate a decrease in cost by maybe a factor of 10. And so that would be like really good if we could do stuff 10 times cheaper. And so I also think this is a great activity for learning about survey research from start to finish. And so that's why we're going to do it. Here's the abstract of the paper, which you could read later. Actually, you've already read. So the activity, you're going to design a questionnaire using questions that have been asked in high-quality surveys. This is going to allow you to compare what you estimate to what people in the past have estimated. Then you're going to recruit participants from Mechanical Turk and have them complete your questionnaire. Then you're going to compare your results to what other people have gotten. You can try then different approaches to weighting and see how these approaches to weighting change your estimates, whether they get you closer or further away from the estimates that we generally think are better than your estimates. Then what you're going to do is de-identify the data and open source it to give you some practice with that as well. So this is going to give you practice designing questionnaires, which is a whole art. And people that do questionnaire design will be I think frustrated that we are spending 2 minutes on it, but it is an important thing. And I think for those of you who have never created a survey, I think just going through this and realizing all the decisions involved will be incredibly helpful as you analyze survey data created by others. Then you'll have practice collecting survey data, analyzing survey data, and this includes both data wrangling and post-stratification. So far we've only talked about post-stratification. There is actually an enormous amount of work that goes into taking the data that you have and turning it into other data that you have in slightly different form. So a lot of this, taking the survey data from MTurk and turning it into the form you need for post-stratification involves a lot of data wrangling. So this will be good practice with that. You'll get practice working with Mechanical Turk, and you'll get practice archiving data. So I want to emphasize one thing, that this is a learning activity, and so you're free to try whatever you want. And so if you want to try something, just try it. Like, it's OK. And let's see what happens. So we're going to tell you the way we think it should be done, but you want to do something different, you can do something different. So here's our recommended workflow. You're going to start by creating a Google form. So we have a template for you. That's the survey data that we have already created. You can use that template, or you can create your own template if you want. We're going to recommend that you use Google Forms because it is free to use. There are other tools, like Qualtrics is a well-known tool that allows you to do surveys. Qualtrics allows you much more control of the questionnaire, but Qualtrics is not free. And so we know there are people who don't have access to Qualtrics, and so we're going to use Google Forms. But if you have a Qualtrics account that you want to use, that's fine. So just to highlight some of the choices involved in creating the form, here are some questions about spending on the budget. So if we were making up the budget for the federal government this year, would you increase spending, decrease spending, or keep spending about the same on the following issues? Military defense, economic assistance, and so on. So you could ask the questions like this in a grid, or you could ask them like this in a list, where you repeat the question each time. So which of these approaches is better? I actually don't know. I don't think we really know for sure, but you could imagine that I know there has been research about this. Also, what order should these questions be in? Should you do them in this order? Should you do them in a different order? Should you randomize the order? These are just some of the many questions that go into doing this apparently simple process of creating the questionnaire. Don't forget to collect the information that you'll need for post-stratification. So you're going to think about what information you're going to want to use to figure out that half the people are men and half the people are women. You'll want to include all of that in your survey. So we have provided for you data from the American Community Survey that includes the information that you would need to post-stratify on gender, age, state of residence, and race ethnicity. Binning those groups. So for example, we've aggregated state of residence to region. We've aggregated age to certain age categories. Race ethnicity is also a very complicated thing to collect. So how exactly should you ask people for that? How should you recode what they tell you? So our recommendation is that you should copy the American Community Survey, like word for word, copy it. So generally, academics think plagiarism is a bad thing. Plagiarism is a bad thing, but plagiarism in survey questions is a good thing. So because word choice matters, it's important that you use the same question as other data sources. And especially if you're an inexperienced survey researcher, if you use a question from a high quality survey, that question is likely to have been pre-tested and it's more likely to give you good answers. So when in doubt, copy questions from other sources. And then obviously acknowledge those other sources in your work. Don't pretend that you made up questions you didn't make up, but use questions that other people have used. So you're going to create your Google form. Then you're going to deploy it to Mechanical Turk. Last year, every single group had a crash in deploying their simple survey onto Mechanical Turk. So that's totally fine. That's great. That's why you're here, is to do stuff that you don't know how to do. But I think you should all expect that there will be at least one hiccup doing this. Then take a break. Once your thing is up on Mechanical Turk, science is happening and you can relax. So last year we did this right outside of a big fountain. And so this is a tweet from Ali. And this is one of her group members outside playing in the fountain while their data is being collected. So in the beginning of Bit by Bit, I talked a little bit about my experience with an experiment and the data was being collected while I slept. And I really think that you all should have this experience at least once, because it's really amazing. Science happening while you are playing in a fountain or sleeping. So while your data is being collected, please don't do any work. That might be a good time to go and have lunch, for example. Or maybe there's a fountain around here. We can ask one of our local hosts. Then after your break, you want to validate and pay the workers. Then what we would recommend is that you analyze a much larger sample that we have created for you. So we have created mTurk accounts for you that have a small budget that you can use to deploy. A lot of these weighting techniques work better with more data. And so we've pre-created a data set for you with about 600 responses. 684 responses. So we would recommend that you work with our pre-created data. If you want to work with your own data, that's fine too. But there are going to be limits to what you can do with the amount of data that you can collect with the money that we've given you. But if you want to use your own money, great. So now I want to give you a quick and dirty tour of the post-stratification methods that we'll use. So what we have done is, in addition to creating the data for you, we have also created a solution for you. So we have actually code working through the methods that I'm about to show you. And you can use that code if you wish, or not use that code if you wish, or use it partially, or whatever you want. So I'm going to give you a quick overview of these techniques. And then as you get to this part in the afternoon, you'll be able to look back at these slides to refresh your memory about what we're doing in the code and how we're going to make these adjustments. OK, so the techniques that we're going to use are called cell-based post-stratification. So again, the idea is we split up the population into groups. We make estimates about each group, and then we combine the estimates from those groups in a kind of weighted average, where the weight in this average is determined by the size of that group. So the key questions are, how do you decide what these groups are? And how do you make this estimate for the average value in that group? So this could be, let's say one of your survey questions might be, do you support President Trump? So how do you estimate the support for President Trump in each of the different groups that you want to combine? So this technique works well under certain conditions. So there is this model, the response homogeneity group model. And if you look at Sarndal section 15.6.2, it explains that model in detail. What I'm going to say to summarize it is, roughly, you want the data within that group to be missing completely at random. So what you want is, within that group, the people you see to be the same as the people that you don't see. There's a more formal statement in Sarndal. Now, if that is not true, then you will get bias. And so here's an expression for the bias. This expression helps us think about how we want to form these groups. And so let me briefly walk through this bias expression. Again, there's a derivation in this book here. The key things here, yi is the attitude. So this would be like, support President Trump, yes or no. And then phi I is the response propensity, the probability to be in the propensity to be in the survey or not. It goes from 0 to 1. So generally, there's going to be bias if there's a correlation between the response probability of inclusion and the attitude. So if people who support President Trump are more likely to participate, that's going to lead to a bias. Under the conditions that also there's variation in the response propensities, and there's variation in the attitudes. So if there's no variation in the attitudes, you can have variation in response probabilities of inclusion, right? So if everyone has the same attitude, it doesn't matter anymore. So as long as there's variation in the attitudes, and there's variation in the probabilities of inclusion, then this correlation is the key thing. We're going to skip this denominator for now. So to build, that's really what you would like to do is you would like to form homogeneous groups such that either there is very little variation in the response propensity within that group, or there's very little variation in the outcome within that group. This is one way to think about what you're trying to do when you choose the groups. Or another way of thinking about it is you want to form groups where the people that you see are like the people that you don't see, where this correlation is approximately 0. And if you can succeed at turning any of these terms into 0 for all the groups, then you're done. You have no bias. Obviously, that was not possible. And you will never know whether you've done that or not, because this is based on unobservable. This expression is in terms of things that are not unobservable, but unobserved. So in practice, you're going to want to form many groups, but then you run into this data size issue. And so there's different ways of estimating the support within each group as you have potentially less and less data about each group. So there's cell-based post-stratification, where you essentially just use the data you have for the people in those groups. So you say, I want to estimate the support for President Trump among Hispanic women between 18 and 29 living in the South. and you say, I have 3 of those people in my sample, so I'll just estimate the support from them from the sample, and that's my estimate for that cell. So that would be like this. Oops, let me say that one more time. That would be, this would come from just a simple sample mean. That's would be kind of your natural first idea about what to do maybe. Now I want to show you how that approach can fail. Basically, even with our sample of 680 people, there's lots of these groups that have no people in them in our sample. So we do not have any female 65 plus Hispanics living in the South. So this approach won't work very well. You need to have some other way of getting an estimate for this group, even though you have no data about this group. So now you can potentially imagine a bunch of things that you might try, right? You could try doing some kind of modeling. You might imagine that people in this group are maybe similar to Hispanics living not in the South. Or maybe female Hispanics are, this group are similar to male Hispanics of all ages, or whatever. You can make up any modeling assumption that you want. And so then we'll see 2 different, more complicated modeling approaches to help you deal with the fact that you don't have data in some of these groups. Or more generally, even if you had data in some of these groups, let's imagine you had only 1 person in this group. You probably wouldn't want to make your estimate based on only 1 person. So you might want to try to borrow some information from nearby groups. And so this technique will help you when some of the cells are empty, and also when some of the cells have very small sample sizes. So one way you can do it is you can create a model. So this is like a logistic regression model. So you want to know the probability that someone will support Trump. You can say is a logistic regression model where the predictors are their gender, their age, their race, and their region. So then you can fit this model to your data. And then if you want to make an estimate for what's the mean support for Trump in this group, female 65 plus Hispanics living in the South, you just take the weights that you get from your estimate and plug in those predictors, and that will give you some mean estimate support for this group. So this is a model-based approach. Now this model obviously makes certain assumptions about the relationships between these groups. And so that is one thing you could do. You can imagine doing many different kinds of models, adding in interactions and other kinds of things. But it all comes to estimate this, the average support in that group. Then I want to tell you about this Mr. P, which I alluded to very briefly in the Xbox study. So this approach uses multi-level regression to like pool data from nearby groups. So this approach was sort of popularized in this paper here. Here's the abstract, and you can read the paper here. There's also a very good, Gelman and Hill have a book, chapter 14 has a good discussion of this multi-level modeling. So here, basically, we're going to add a model on top of those different coefficients. So instead of having a dummy for each of these groups, we're going to add a model, and we're going to model those terms, and that's going to help do some partial pooling. So if you've never done multi-level modeling, obviously, you're not going to understand what I've just said. That's fine. Someone in your group will have done it before. And you can also focus on any other technique you want to try to estimate the average in each of these groups. So modeling allows you to make more estimates for smaller groups. It also brings in new assumptions. You have to add some assumptions to get these estimates for the smaller groups. These techniques are widely used by modern pollsters and political scientists. These same techniques can also be used for small area estimation. So essentially what we're trying to do is we're trying to make estimates about very small groups of people with limited data about those people. So one way that this has been used in other, by political scientists in other settings is, let's imagine you have national level polling data and you want to estimate attitudes at the state level. So you can imagine trying to build using these same kinds of modeling techniques to make estimates about small groups. To learn more about Mr. P, obviously we don't have time to talk about it in great detail. Here are a number of papers that are both optimistic, and there are also some papers that are pessimistic. You should understand more about the assumptions involved in this technique if you're going to use it for real. If you're going to use it for a group activity, you can just use it and see what happens. So this, again, is our recommended workflow. We're going to come back together at 3:15 at this site. That will not be live streamed. So when we come back at 3:15, the live stream will be off. And then we are going to talk about what we learned, and we're going to talk about de-identifying our data, and everyone will have their data posted, hopefully before the speaker starts, and definitely before you get dinner. So if you want dinner, your data has to be posted. So that is it, and we are on time. So now let's get started. We're going to turn off the live stream, and remember, your goal now is to get your survey up and running and take a break. Let's begin. Thank you, everyone. Bye-bye. If you have any questions, you can add them to the Slack.